the formula per se. We learned how to put it in our calculators and type some stuff in and hit enter. So we didn't really get a sense of what this formula is, why it works the way it does, and things like that. And unfortunately today, because of the shortened periods, we're still not going to get a sense of why it works the way it does and what it is. Tomorrow we will. This actually, I can give you a sense of. This is actually what you would get, I'm stealing my own thunder a little bit, if you were to use the completing the square approach to solve this equation for x. All right, so this equation with a, b, and c still in it, not replaced with numbers.
Is there a plus or minus button?
There is not. So we have to do it separately. But it's, you know, that whole blank space above this in your, there's a reason why there's a whole blank space. It's a bunch of steps to get to the solution. All right, so actually, if I were to do that today to show you where this came from, that would take the whole period. All right, so the first 20 minutes of class tomorrow, you know what we're doing now. All right, so we're going to invent this formula, which is really cool. Math cool, of course. So,
Which is cool.
Which is, of course, cool. Definition. So what we're going to do at this point is just really learn how to use it. So we have three coefficients, an a value, a b value, and a c value. And we have a formula that has a's, b's, and c's in it. So x would be equal to, I'm gonna put parentheses wherever there's a
Variable.
That's the thing. I wanted to call it a variable. It feels like a variable, but they're actually constants.
Constant.
It's just strange to think of it that way, though.
An A, B, or C.
Yeah, wherever there's an a, b, or c, I'm going to put parentheses.
Here, Ren.
This is your fallback option if you don't like completing the square. All right, so if you were thinking of that as like, man, I'm glad we're done with that completing the square. I hated that. And then immediately we start learning about this, and you're like, oh, I hate this too. I'm like, well, you gotta like something, because otherwise you're not gonna get any answers correct. All right, so
Oh, wait, is this an alternate for?
this is an alternate when you have a choice.
Why would anyone ever choose this?
You'll see in a minute. You'll see in a minute.
You're
You
so
put
right.
it in the middle.
Whatever.
Yeah, honestly, I didn't learn how to properly space my work till I became a teacher.
Wait, why did you put the 2 on the bottom and you flip like the 2 and the 3 like on the right side?
It's 2x squared.
Oh,
Just following
I
the
didn't
law.
see that. Yeah.
Oh, it's
Oh, it's right
just
there.
exactly
Well, if you're
Why
not
on
used to
earth
it,
did you do that?
I'm just confusing the force.
Does he get the
It's a formula that once you become more comfortable with it, it'll become more obvious why we do what we do.
Wait.
But until you get there, it's going to be like, where do these numbers come from? So,
But is
It's
this
understandable.
like a concept thing, or is this just all memorization of that formula?
for today, it's memorization. Tomorrow it becomes a concept. After that, it becomes a choice. Because if you get the concept, then you don't have to memorize.
You don't know that.
You don't know
You
that.
don't know how to do it yet.
Right, that's the
He
thing.
would
Just
give it
look
to
at
us
that.
if we were all going to choose the other one.
Yeah, right. He has to give it to us.
Actually, yeah, it's kind of. Actually, I don't know.
By the state.
All right, so just simplifying a little bit. Negative 5 is just negative 5. 5 squared, 25, and then negative 4 times 2 times negative 3 will give you a 24, which very nicely cleans up.
So you would use this for the sake of, since you can't like divide 5 by 2 and 3 by 2 easily?
Right. Yeah, because if you try doing this with completing the square, you get messy numbers right from the get-go. So you think to yourself, oh, I don't want to factor, so what's my other option? It's this. But as it turns out, this one would have been factorable So if you have a choice, you may opt for factoring if that's something that you particularly enjoy doing. Square root of 49? So we have two possible solutions here. We break it up. We're looking at negative 5 minus 7 over 4. Or negative 5 plus 7 over 4. Negative 5 minus 7 is?
Negative 12.
Over 4.
Negative 3.
Or now negative 5 plus 7 is? Over 4? 1/2. So this would be x such that x is equal to either of those.
Oh man, that was a
That was, look at that. And again, to know that it was factorable to begin with, maybe makes it sting a little bit more, I don't know. But this is an X chart factoring situation with grouping and things like that, so maybe you still would prefer to do it. This is one of those topics. I personally, as a student, I was like, this sucks. I don't want to do this. But then I got to a point where the quadratic formula became second nature. Because you're going to do this so often over the next bunch of years that you're never going to forget this formula. You're going to be like 50 years old. You're not going to remember anything else except for the quadratic formula and the Pythagorean theorem. Like that's it, unless you become a math teacher.
Yeah, you don't know it.
I thought that was like
A squared plus B squared equals C squared.
Something.
A squared plus B.
It has A's, B's, and C's in it.
And an x if you
But
think
But
of it.
isn't that
being
another
plus
times
B
squared
As
equals C
close to
squared?
being standard form of a linear equation.
Oh yeah.
I think it does normal.
All right, so a few weeks ago,
Yes, it is.
I had you do something in your calculator, and we're going to find out now if you actually did it. So, hit the program key.
Oh, this again.
Well, if you didn't do it right, that's a different story. We'll figure it out. So you hit the program key.
Can you help me find the? Never mind.
Oh man.
Where is it? What does QF stand for?
That's the program.
That's the one we made. Waha.
Oh.
It's like I had a plan all
How did you
along.
get to that?
Oh boy.
Program.
Yeah.
I heard that's an
Haven't done anything with it yet.
It should be under the exact, right?
Under exact. Yeah,
Which is
execute.
exactly where nothing is. So.
All right.
I don't know if you didn't do it, Lucas. I did do it too. I saw you do it on this calculator, and that's really. Oh,
It might have got reset.
oh man.
If your battery's not
You
reset.
don't have it.
Mr. Kent, I don't have it.
Yeah, I don't have it either.
Outrageous. It'll be alright. I can dump it into your calculator.
Oh, so
So,
I wasn't wrong.
He used me.
You didn't do anything. No, but you have to.
yeah, everybody who like opted out and decided they didn't want to focus and pay attention that day and put the program in, I'll help you. I'll give you the program. No, I'm just kidding. Some people were absent, and actually, in some cases, even if you did do it,
It didn't save.
Oh, is
Well,
this the
that's not a
long
thing.
thing that
When
we
it
did?
died.
yeah,
Oh, that's
it
so
died.
Oh.
You typed in something incorrectly. Yeah, yours definitely died because we had to recharge it.
I have no idea.
So things like that happen. You're gonna have repeatedly a need to put programs back in your calculator before it's all said and done. So hit QF, hit enter on the QF program, hit enter again to actually run the program. It asks you for an A value. Oh, look, we have one. A B value. Hit the 5 and the enter. Then a -3.
Are you getting more
Oh,
lines?
I do that.
How'd you get another?
What does that
Yeah.
mean?
How'd you get
Oh,
B
that's it.
Oh.
How do you get what?
Like B equals.
You hit enter after you type in the A.
So you just
Why does the calculator know how to do this?
Okay, so you might be one of the
Why do we
candidates
learn
for
this
a
math?
Yeah.
program
Mr.
upgrade.
Kent, why do we learn the math? We can just do this.
Yeah, I'll get you set up in a few minutes.
I'm on a show word.
Wait, Mr. Kent, why don't we just learn how to use calculators from like kindergarten, and then now we would just do everything with the calculator.
So what if
See, it's the other way around. It should be like no calculators until this point.
Oh, and then because you
Like never use a calculator, get the concepts down, and then it's like, all right, now all calculators all the time.
I think but if we learned calculators from like kindergarten, we would just know how to do everything on the calculator. Which is
Yeah,
the
there's
same.
one specific device.
Hey.
Believe it or not, we actually do graduate beyond using these calculators.
Mr.
That's
Can.
There are
the
more
thing.
complicated.
Hi,
Oh,
Mr.
there's
Can.
like,
This, what?
New calculators
I'll help you.
called the Hepler.
folks, anybody with calculator problems, I'm gonna get you squared away all in one shot at the end. So just sit tight, if you wouldn't mind.
It's just his math.
It's like square.
It sure is. It sure is.
It is all exact testing quizzes put into it.
So, the second problem, see how there's no coefficient in front of the x squared? That means that there's an assumed 1. So we have a, b, and c. So quadratic formula, again, x equals negative b plus or minus the square root of b squared minus 4ac.
Can we memorize that?
Mm-hmm. All over 2a. And then plug in your value. So again, it's negative b, so 3, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. So in this case, we get negative 3, plus or minus what's the entire radical?
29.
What
29?
29, yeah. Now this is the best possible situation.
Wait, never mind, I got it. I was gonna ask why it's -3, but.
Oh, yeah, it's okay.
Yeah, you did it.
Alright, so this is the best possible situation because
And why?
there's nothing else you can do beyond this step.
So that's just yours.
So this is your answer.
Let's go.
X
Yeah, perfect.
such that this is where the calculator program can be useful, but it's not the end all because all it's going to do is give you a decimal equivalent. So if I run the program, coefficients 1, 3, -5, I get these two decimals, which is definitely not looking like this. But if I just choose one of these, like -3 minus rad 29, over 2, you can see that that corresponds with one of the solutions. And then just do the same thing again for the positive we have to do them separately. You see that corresponds with the other one. All right, so you could use it when you're dealing with radical answers. You could do it. You could use it for a checking purpose, but it's not going to solve it for you like it would for the other cases. So just thinking in terms of a multiple choice question on a test, for something like number 1, could do the whole problem for you. For something like number 2, best it could do is help you verify that your answer is correct. All right.
But how do you know that that's?
Well, that's the thing. Well, how do I know that this is the equivalent fraction? You just you type it in and see if it matches up the quadratic formula. But a byproduct of that is, I mean, it involves a radical. What if you need to simplify radicals along the way? If that's the case, you could already see the multiple choice question. One of them has a radical 60, for example, and the other one has a 2 radical 15. They both are the same value, but one of them is a simpler form than the other. So simplifying radicals still has a part to play in all of this, right? So you'll need to be able to do that. I don't know any more. 10 minutes? All right, we can get another one in. Derive means basically invent. I mean, it doesn't, but that's our interpretation of it. It actually means that something emerges from something else. So you could think of pretty much any form of growth as a form of derivation or derivative. So you might have heard the term derivative for stocks, like in a financial sense. So a stock derivative is you're taking the stocks that you had and using those to produce new stocks, right? At least as far as I understand anyway. Math teacher, not financier. Anyway, we're going to take that equation and an approach that we already know and use it to derive a new equation. right? And we already know what this new equation is going to be for two reasons. One, we played around with it a little bit yesterday, but also, it says it right there. I meant to use a marker. I ended up using a highlighter, but I'm going to live with the consequences, much like life. All right, so ax squared plus bx plus c equals 0. So if we are completing the square, you have a choice in your first step. All right, some people like to do getting rid of the c value first. Some people like to get rid of the a value first. So I'm going to get rid of the a value first, and there's a good segment of the population who be like, I wouldn't have done that first. Okay, then don't. So subtract off the c if you want, if that's something that you want to do first. I leave it up to you. So you'll catch up to my second step. My first step will be your second step, and it'll be fine. All right, so I'm going to divide everything by a. Honestly, I'm only dividing everything by a so I don't forget to do it. That's why I do it first. I don't want to take a chance. All right, it would cancel in the first fraction, right? Because a divided by a is equal to 1. I'm going to make a little note of the 1 there, just so you know that that first term doesn't zero out. Now, the second and third terms, those are going to be fractional. You're going to have x squared plus b over a times x plus c over a equals, what's 0 over a? That one does zero out, so we get 0.
Why isn't the x getting divided by a with the b?
You can make it bx over a, but you can also write it like this. Yeah, it's like 2x over 3 is the same as 2/3 x. Right. I write it like this so it's easy to identify what the coefficients are. That's personal preference. So now I'm going to get rid of the c over a. That last term, that needs to go to the other side. You may have done that first, and that's fine. Cancels on the left. It's on the right as a new fraction. I'm going to leave a little gap in its place because we are completing the square. All right, so now it's going to get a little complicated, right? Because this part is all procedural. It's ugly, I'll give you that, but it's not difficult. I mean, there's 2 steps that we followed. They're pretty consistent with what we've been doing in class with the numbers, right? But here it's going to get a little funky. So normally what we would do is we would take whatever our b value is, in this case it's b over a, cut it in half, and square the result. But that's going to take a little bit more work. All right, I'm going to rewrite that as b over a divided by, if I wanted to write 2 as a fraction, what would that fraction be? 2 over 1. Now, I have a division within these parentheses. It's b over a divided by 2 over 1. If I wanted to write that as multiplication, what would I write? B over a. Instead of b over a divided by 2 over 1, I would times 1/2, yeah. All right. When you're multiplying fractions, you multiply the tops against each other and the bottoms against each other. So b times 1 is b. A times 2 is 2a. What do I get if I take b over 2a and square it? What does the top become? B squared. What does the 2 on the bottom become? So 4a squared. All right, so b squared over 4a squared. All right, so instead of having like a nice 4 or a 9 or a 16 or a 25 to plug into the gaps, we have a nice b squared over 4a squared to plug into the gap. That's beautiful. Precisely what you had in mind, I would imagine. Okay, so I'm going to pop that in. So I'm going to add that to both sides. Let me just shove this over a little bit. So this, I'm going to just draw little arrows. Right there. Look at that. I always like to stop and smell the roses a little bit because at this point it's kind of, I mean, to look at this, and you saw the quadratic formula yesterday. To look at this and imagine that this is somehow going to become that, I don't see it, you know, or at least I wouldn't see it yet, but it will. And it's a pretty cool experience when it happens. So I'm going to go. Hey, so we're going to continue on. We have to simplify this. Now, the left-hand side is, believe it or not, I mean, it's a glorious mess, but it's actually the easiest part of this because this is a perfect square trinomial, whether you believe it or not. It's going to factor to a binomial squared. Just like it would in the completing the square process. Right? So when we complete the square, using a trinomial, a perfect square trinomial, we take the square root of the first term. What's the square root of x squared? X. We carry down the middle sign. What's the square root of b squared over 4a squared? B over 2a. All right. The right-hand side we have to simplify. So I'm going to rewrite that expression. We have to get a common denominator and put that all together. All right, I left a little space after the negative c over a. I did that so that I can get a common denominator. What would I have to multiply the first fraction by top and bottom to make the denominators the same? Well, what's missing in that first denominator? A 4. What else? And an a. So 4a over 4a. All right, so left-hand side is going to stay put. The right-hand side, if I multiply those two fractions, I'm going to get negative 4ac over 4a plus, 4a squared, plus b squared over 4a squared. When you add fractions, you keep the denominators and add the numerators. So it's all going to be over 4a squared. What's the top going to be? If I add those two numerators together. Negative 4ac plus b squared, but there's a nicer way to write it. Just thinking about where this thing's going.
Negative 4a b squared c.
B squared minus 4ac.
B squared minus 4ac. All right. So left-hand side is x plus b over 2a squared. I want to get rid of the power of 2, so what do? Square root it. All right. Squaring it means something different. What does squaring it mean? multiplying by itself or raising it to the second power. So square rooting it is going the other way. So we want to say it the right way. 'Cause if you say it correctly, you'll think it correctly, and when it comes time to write it on a test, Regents exam, you'll write it correctly. Because I'll tell you that I don't always teach this course, but I always have to grade these exams. And it's stuff like that that keeps people from getting a perfect score on the free response. It's not the math. The math is almost always right, for assuming the person has an idea of what they're doing going into the test. It's almost always like a missing word that messes everything up. So on the left-hand side, we're good. We just killed the power of 2. X plus b over 2a. On the right-hand side, so on the top, we can't do anything with that because it's not a perfect square, right? But on the bottom, we do have a perfect square. What is the square root of 4a squared? 2a. On the top, I just have to leave it as a radical. But I am taking the square root, so what should go in the front? Whenever I take the square root, what symbol needs to go in the front? Plus or minus. Very good. All right. Pretty much there, because if I want to get x alone, what do I need to do? Subtract b over 2a. So we'll have negative b over 2a. Then we have this plus or minus the radical b squared minus 4ac over 2a. They have a common denominator. Put it all together, and you have negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. I'm trying to remember what that old saying is. It's a famous one. I can't remember who said it, but it's something along the lines of technology that's sufficiently advanced is indistinguishable from magic. I think it's something along those lines.
So the conclusion we just arrived at, like, isn't that more, like, complicated than the original?
Yeah, but you can't do anything with the original.
Oh, okay. So then what was, like, the overall purpose?
We now have a formula that we can use to solve any quadratic under any circumstance. And we could also, if we needed to, store it into our calculators to let our calculator do the solutions for us. Quadratic formula doesn't exist without this process. This is the origin story behind the quadratic formula. This is how the formula is built.
Is this how they found it? Like,
This is how it was discovered.
so wait, they find formulas by doing math questions?
Yeah, in general forms. That's the thing. People, they try to solve questions that have numerical values in it, like 2x squared plus whatever. They go through the process enough times where they say, there's got to be a shortcut to this. So what they do is they say, well, let me not put numbers in here, let me put letters in there and see what I get as a result. When they did it in this case, they came up with that formula and they said, all I need to do is plug in A, B's, and C's, and I can get it all in one shot. This is great. So the requirement from the state, New York State, is that you know how this formula came to be, and you are responsible for following this process, right? And by the way, I know some of you are interested in honors and gap. This is a regular occurrence in honors. This happens from time to time in the regular level in gap. All right, so like if you're thinking, if this is something that interests you and you want to see a lot more of it, honors is the way to go because that's where you get it.
So, by having done this, like, the point was for us to understand, like, the origin behind it?
The process by which the formula was developed.
But do we
Okay.
need to know the process?
Yes,
But you should.
We need to know that.
yes.